Let's talk about binary search now. So see, there are multiple searching algorithms. One of them is one of the one of the things that you will notice after a couple of days or a couple of hours into learning into searching algorithms is that most of the searching algorithms that you will see work only for sorted arrays. That means if the array is sorted, they will work nice and fine. If they are not, they will create an issue for you. So what is linear search? Linear search is one of the very few search algorithms, which work for unsorted array. You have you are given an array, okay, 5, 9, 2, 1, 3. Simply what linear search does is you need to go through each of these elements. You are given a target value. Say you want to search 1. Okay, this is your target value. You go to each of these elements by traversing through the array, and then as soon as you see 1, you return that index. So for example, here this is the third index, right? So your output becomes 3. This is a very simple searching algorithm, and there is nothing more to it. This is not something that is asked in interviews. This is not something that we use in our daily life. So this is something that I just wanted to quickly go through. There's nothing more to this. So now let's talk about binary search. So what is binary search? As I said, it's basically, it works for sorted array. So say if I give you a book, sorry, not a book, a dictionary. Okay, I am giving you a dictionary and I want you to find the word logic. So how will you find it in a dictionary? Well, you will open, what will you do? You will first open a page and you see that, all of the words that you are seeing starts with the letter D. So, and this is on, say, page 62. Okay, you have opened a random page, page 62. You saw that the letters that are appearing are, starting with the letter D. So that means logic, which starts with L, is definitely on the right-hand side of the book. So what do? Everything from 0 to 62, you ignore. And then you open another page. Let's say now you opened a page where everything is starting with P, and you are on, page 234. And every word in there is starting with the word sorry. So every word is starting with the letter P. Okay. So what do? For example, if this is the 500 page, dictionary, you will ignore everything from 234 to 500. Why? Because the word logic, the word L does not come after P. So you can easily ignore this. And you will only search between 62 and 234. And you keep on reducing. So what are you doing right now? You are reducing your search space so that you can, go to the exact point where you are, exact place where your word is supposed to be. This is what you are doing, right? Binary search also does the same thing. But we are choosing the pages randomly. We opened the page at 62, we opened the page at 234. There's no pattern here. Next time you open, you might not go to 62, you might go to 74. Something like this will happen, right? This is very uncertain. Binary search will always go to the middle element. So if you're given a 500 page book, it will always go to page 250 first. Then it will check if the word is on the page 250. If it is not, it will check whether it is on the left-hand side or the right-hand side of it. Say if it is on the left-hand side of it, it will ignore everything between 500 and 250. And it will again start from 0 to 250. It will again start the same search from 0 to 250. Let's see how this actually looks like in, in a coding environment, basically. So there's nothing complex about binary search that is out there. So whenever you are given an array, let me quickly create an array. Say it should be a sorted array. Binary search only works for sorted array. This I cannot stress enough on this topic, because many people try to use this on an unsorted array and then get caught up in it. So binary search only works in a sorted array. So let's say if you are given an array 2, 5, 7, 9, 3, sorry, 31, say, or 30. Okay. And let's take one more, 51. Okay, now you want to search 9. Okay, you want to search your target is 9. What do? There are 6 elements, so you go to the middle element, which is the third element. Okay, as soon as you have gone to the third element, you check, is this the number am I looking for? Am I searching for 7? You're not searching for 7. Then this is your first question, is 7 equals 9? It is not, right? Then you check, is 7 less than 9? 7 is less than 9, right? So what do? So at start, you keep your low and your high. Okay, these are two variables which point, one points at the start of the search space, one points to the end of the search space. So now you check, is 7 is less than 9? 7 is less than 9, right? So what do? We ignore this part because it cannot be in here. So we pick up our low and we put it here. Low is now pointing to here, 9. Now what do? We again find the middle element. Which is the middle element? It is 30, right? So what do? We again check, is 30 the target? Is 30 equals 9? It is not, right? Then we check, is 30 less than 9? 30 is not less than 9, right? Then what do? We ignore the right hand side and we pick our high up and we put it at the same position where low is. Now since high and low are at the same position, the mid is also at this position. So what do? Mid basically becomes, we again check the mid element, is the mid element equal to 9. So this time when we check, is 9 equals 9, we do get a true value from it. And so we return this index, which is 0, first, second, third. We return the third index as the output. Let's look at the code once to understand what is actually going on. So ignore this part for now. Okay. So here, see, binary search can be done in two ways. One is with recursion, one is using iteration. We will look at both of the code. But first, let's look at recursion. We find the mid value, okay, which is basically start plus end by 2. That is how we find mid, right? So if I give you what is the middle element between 4 and 10, what do? Basically, you say 7. But how do you get this 7? Like 7 is the middle point between 4 and 10, right? How do we got it? We simply added 4 and 10 and then divided it by 2 to get 7. This is what we do, right? So same logic we are doing here. We are finding the middle by doing starting and ending and then dividing it by 2. Now what do? We check, is the middle element the target? If it is, we return the mid. This is what we were doing, right? Is 7 equals 9? Is array mid equals target? If it is, we returned the index. If it is not, then what do? We do if array mid is less than target. So basically, if it is less than target, if the middle element 7 is less than target, what do? We call the binary search method again. This is recursion. The function is calling itself. So now what do? So see, the binary search algorithm expects 4 things. The third is the array, the fourth is the target. Those are common. Those are common for everything. But for the start and the end, these are the start value, this is the end value. So for the start value, what I gave mid plus 1. This time, when I called binary search, I put start as mid plus 1 here. So now when this went over, the start actually became mid plus 1 in that case. It basically, it's not that complex. It just means that yahan low tha, ise maine utha ke yahan dala. Okay, I picked up from there and I put it over there. Okay, same thing we do with high. If this is not the case, then definitely this is the case where what am I doing? Instead of end, I'm doing mid minus 1. Like start remains the same, the mid minus 1 becomes the end value. So this is basically binary search. And I have also put the iterative version as well. It's the same thing, just we are doing low is equal to mid plus 1 and high is equal to mid minus 1. It's the same thing, just we are using a while loop. So this I'm giving you as an assignment. Don't look at the solution now. Try to write a iterative